Hey everybody, let me show you what we got going on here today. We got this HP, which is overheating. It's getting hot right away. The fan is working. Fan is working. It's blowing cool. We actually blew out the fan already with compressed air. No noise, no anything, but it's super hot. So let's take a look. Let me show you. I got core temp. Gonna run core temp, which we've done videos on before. Core temp. We'll put a link also if you want to take a look at that software. Let me crank down here a little bit. Got a big glare there, I could see. Might be a little better. All right, so right now we're at 54 degrees. Okay. That's not bad. We're not doing anything. Let's just open up a browser. It was hitting 100 degrees. So something's going on. Either the thermal paste is bad, which usually it wouldn't be so dramatic, or the sensors are giving the wrong reading. Let's take a look. So we'll just run a video. It's cool here. I'm right under the AC, so it's already at 70. Go to YouTube. It's at 91 degrees already. So there's 94. Yeah. So there's really not a whole lot to do. It just creeps right up, and that's the problem that the customer was having. It would just turn right off. So I don't know if you could see that. Probably can't see that, but it's at 90 degrees right now. If it wasn't for that glare right there. All right. And like I said, that fan is blowing, and it doesn't even feel warm. Usually, if it's that hot, I mean, you would feel this. It's 100 degrees. You would feel this. So maybe it's just a sensor giving a wrong reading. I don't know. So we're gonna open up, take a peek, and see what we see. All right, so let's get to it. Pop that battery off. So everything here seems pretty normal. We're gonna take the board out and see what the heck is going on. So just lift it up, try it up slowly, make sure you don't got nothing hanging around. And yeah, there's a flex. Yeah, the power jack flex goes underneath. Exactly. All right. That's what I wanted to see, if there was a good flow going on, but we're gonna find out. So what I thought, maybe there was something going on here as far as the flow, but no, there's perfect flow. I'm gonna reapply the thermal paste. I'm leaning towards, I doubt that. I did do one recently that the temps did drop like 10 degrees. So we're gonna try that and see. And we'll just reapply some thermal paste. And there's 10 different ways to do this. What I like to do is, I'll call it the, well, you call it the spread method, but I kind of spread but dab. I don't like to do the drop and then it just goes wherever it goes, and maybe it's too much or maybe it's too little. So I'll put some, I'll make like a little cross, and then yeah, you don't want to get your fingers dirty, but I just kind of, you can spread it, but in the end, whoa, I got too much on here. Way too much. If you just dab it, eventually it'll equal out, but I got way too much on here. So I just kind of do that, and then eventually, if you do that, it will even out. Got a little bit too much in the middle, but if you keep doing that, it'll just even out. You'll have a nice little even film across the top. I mean, that's a very, 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 very even, and you don't have all this flow going all over the place on the sides. And then when we close it, I mean, you'll have a little spread. But if you got your own method, happy face, crisscross, a heart, no problem. You can do that. So I'm going to take in the back and actually clean it. So this, I just cleaned it. I did put some soap and water and blew it out, dry it out, but it seemed super clean. So let's put it back and see what happens. Could it be just a heat transfer problem? Well, we're going to find out. Now, my understanding is that these heat sinks, this copper bar has something inside, whether it be a liquid or a chemical. Gonna have to look that up. And then, of course, if that's the case, then the actual heatsink could be bad. I gave it a little bit of a brush, but it's clean. All right, now you gotta get all your flexes up and out. You got those two. That one's coming off the top. That one. Is it there? I guess it was. When you get these to pop in, make sure it just sits properly. You shouldn't have any pressure. If you do have any pressure, anything bumping up, it's probably a little cable like this one that got stuck underneath. Speaker cable. You know, so it should sit without any pressure. Otherwise, there's probably something out of place. These USBs, remember, they gotta kind of fit right in there. That's gonna go right there. So that looks pretty good. So pop these. What was it? Three motherboard screws. Jeez. So let's get these. And I'm hoping this is the case, because if it's not, I mean, we would have to replace the heatsink, but you know, the parts for these, the replacement heatsink is going to be a used one as well. So how much better is it going to be? Okay, that one, that one. And this we don't really need right now, but I'll just put it back in. Will it be shrunk? Think shrunk, it doesn't fit now. It doesn't have a little tab. So let me just grab me from here. Yeah, so here I'm not gonna put the whole keyboard on. Basically, I just took off the power flex from the keyboard. Yeah, just get the power button from the keyboard, and then I could just test it right here. I don't need a keyboard. I don't need a trackpad. We're gonna get a wireless keyboard. Just get a wireless keyboard right here. Boom. We'll be able to test it right there. We need power. I took the battery out, so we'll just get a power cord. Now the the airflow without the keyboard on top might be a little different without the palm rest, but let's just see what happens. I'm as curious as you are. Everything's connected. Yeah, let's give it a shot. And I think we're good. Let's try it out. Whoa, this thing is gonna flip back. Can't move that LCD too far back because it'll flip back on us. So we'll try it here. We don't have the battery in place. That fan is blowing 100%. Why is that? So let's take a look at core temp and see what we got. Holy cow, 92 degrees. Yeah, there's definitely a problem here. That's why that fan is blowing full blast. Of course, yeah, the airflow is not flowing right, but that still should not be at idling at that temperature. There's some, it could be a bad sensor, and it's just not really at that temperature. It hasn't shut down on me, but it has been shutting down on the customer. You would think when it hits that 97 degrees or right around there, it should just shut right off. There's no load on the cores. Fresh thermal, airflow is perfect. I mean, that is flowing, regardless if this was open or not. Wow, I mean, this thing is blowing. That fan can blow. Wow. 85 degrees. It hit 93. I'm sure if we run, yeah. And these heat sinks last, I mean, they last a lifetime, but maybe there's something wrong with it. You know, I probably should have given it a little bit better inspection, frankly. And maybe it does. Sometimes you can notice a little, hole in it or some oxidation or something that you could physically see wrong with it. Yeah. All right, so we're going to wrap it up for there. I'm going to check parts. I'm going to check for availability of a replacement heatsink. So we'll try that. I'm going to try some other software and verify if that temperature is accurate. Hey guys, so here we are back with the HP 15 P390 and R, which was getting hot. So we ordered a heatsink, because when you would touch the heatsink, you would feel it really hot here, but the temperature wouldn't travel. You know, this would stay cold. The air coming out of here was still cold. So we ordered another heatsink from eBay, and it came in and it was the same. It was a used heatsink, and it had the same problem. So that made us scratch our head even more. We said, I mean, another bad heatsink? But apparently so. And as we did some more searching online, this is obviously a common problem with this unit. So there was none available. Actually, there was one more available, but it was from the US. So, you know, how do we know that one was going to not have a problem? So we just decided to just order one from China. That was the only thing available, which we really hesitate to do that just because it's going to take so long. And then if it has a problem, you know, kind of same thing. You could return it, but it's just more of a hassle. So we popped it on there, and those are the temperatures. Right now it's idling, right, at 37. This was hitting 100 idle without doing anything. So, and now of course when you touch it, you know, actually, well, now it's just super cold. But it would, even at idle, it would be super hot, and as you would touch here, you know, this would never get hot at all, but it'd be burning right there. 100 and something degrees. I don't know if that was Celsius or Fahrenheit. So let's give it a little crank here where stress my PC. It's a little software you can use to give it a little quick stress. So let's, you can hit up there for CPU stress, paint stress, which would be GPU. Oh shoot, it was on. I don't know it was on. Did I click it on? It was on. Alright, so it's on now. So you can see there the load. It puts you got 4 cores. So the 4 cores, right? 100, 100, 180. It's more than what typical use is going to do. And that temperature is not moving at all. Sheesh. Talk about cool. Now it's going to be too cold now. What a difference. So you would ask, right? Because I'm asking, what's the difference in the heatsink? Apparently there's, you know, my understanding is there's a gas or some type of liquid inside that as it heats, it, you know, travels to one side or another, something like that. If anybody out there's got a better explanation, which I'm pretty sure everybody will, post it here, because I really can't explain why, how that dissipates the heat. I mean, aside from the fact that you got the fins here at the end, right? That we know, right? But the travel, right? You got a piece of copper. What makes that travel? The other one wouldn't travel. It would go like halfway here. That was it. It wouldn't keep going. Interesting. So that's the deal there. Replace the heatsink. We're gonna put it back together, and it's gonna be a wrap. So we'll come back to it once it's up, running, and put together. And there she is, assembled. It's a nice little computer. It's got this red color scheme, beats. So she's running cold as ice now. Maybe too cold now. So that's the idle now. We're hitting 100. 34 degrees. Let's crank it up. You can see there the load. There's no load on there. Stress it out. So that's Stress My PC. You could download that online if you want to run a little stress on your computer. And then that's Core Temp right there. Also, you can just download that if you want to check your temperatures, and then you can see the load right there. And then this, you know, it's gonna stress it out. Simple little program, works pretty good. If you got a really heavy duty computer, then you might want to use something else to give it a little bit more. But I mean, this here pretty good right there. You got all three. You got 3 cores at 100 and another one at 64. I mean, that's more than what typical use is gonna stress it. And damn, this thing is cold. 43 degrees. Yeah, so what we're gonna do, I was just talking to another tech and I was telling them that, you know, we had a bad heatsink, and you know, of course, like, what do you mean, how could it be bad? Is it dirty? No, just the heatsink is bad. So it's hard to believe. So what we're gonna do with this one is I'm gonna cut this thing in half and take a look so we can get down to the mystery of the heatsink. So we're gonna see what's inside this thing. Hey everybody, so we're gonna open up this heatsink and see what's inside. Supposedly there's either a gas or a liquid. There's something in there which makes the heat travel from one side to the other. The other heatsink looks exactly like this one, but no heat transfer. There's no heat travel. So let's see what's in here. Maybe nothing. Hollow. You would think that if there was nothing inside, it wouldn't be hollow, right? So, I mean, if you really wanted to conduct it and it didn't have some special liquid gas or something, obviously, we didn't see a gas. Maybe it's a light gas. We didn't even see it. Actually, I'm going to cut all the way through. Just cut a little deeper. So it has to have something in there. Otherwise, it would be just a solid piece of copper, right? Why would you have a hollow piece of copper unless there was something in there? And now I got a little jam. And did a couple of searches on the web, and people talk about it, but some say it could be a liquid, it could be a gas, it could be empty. I don't know. Tell me what you think in the notes. I mean, in the notes. In the comments. I don't see nothing in here. So if there's a liquid in there, or maybe this one, maybe that's why it doesn't work, right? So the bottom line is, we didn't find anything in there. So the mystery remains a mystery. What's inside a heatsink? I don't know.
And that's what's going on tonight at PC 911. And I'm back with the heatsink because we're still curious about it. And when we split it, when we opened it, we kind of saw it a little bit dark, and we got curious and split it open. So we split it. We find all this dark material inside. You can see kind of, I don't know what it is. Obviously, it's not dirt, right? So again, going back to whatever chemical is in there, liquid, maybe it got crusted, maybe some oxygen got in there and started corroding the inside. So this is the bad heatsink. So then our question was, maybe it's like that. Maybe it's supposed to be dark and it's a special material to transfer heat, but apparently not. We got some other heat sinks that we found back there, and when you open it, I mean, it's supposed to be crystal clean. We got a couple different ones just out of curiosity to see what's going on. So no, they're supposed to just be pure clean copper inside. And there's even another one over here, so you can see they should be super clean inside. So this heatsink, something happened with it. And of course, the proof is in the pudding. We changed the heatsink, the computer's working perfect. So problem solved. And that's, again, what's going on at PC 911.